Today's lesson will be using math drawings to represent the composition when adding a 2-digit and a 3-digit add-in. As you can see, I've written 34 plus 18 in vertical form, so we are going to continue that method moving forward. And this time, my place value chart looks a little different. I've labeled the tens place and the ones place. So this means that we don't have to label the discs anymore because the discs in the ones place is a 1 and the discs in the 10 place will represent a 10. So the place value tells us the value or how much the disc is worth. So now as I model each of the add-ins, you'll see I will just draw dots and we'll call this the chip model. And the dots represent the chips. And this model is easier and takes a whole lot less time. So watch as I count to add 34 plus 18. 10, 20, 30, 31, 32, 33, 34. So there I've added 3 tens and 4 ones to represent 34. And 18, 10, 11, 12, 13, 14, 15, 16, 17, 18. And now I have 1 10 and 8 ones to represent 18. Also pay attention to how I've organized my chips. Just like the place value discs, I have it straight underneath the others so that I can easily see there's 5 on top and 3 below to make 8, and then I just need 2 more to make a new 10. So I can circle those 10 without even having to count because I've organized it. And because I composed a new 10, actually I forgot to do the chip model there, sorry about that. We are going to add a new chip to the tens, which means I add a new 10 below. And how many ones do I have left over? I have 2 in the ones place. So 2 ones. And then how many tens? 1, 2, 3, 4, plus our new one is 5 tens. So 5 tens and 2 ones is 52. Pay attention down here. I have a word underlined. This is a new vocabulary word that we will refer to called algorithm. And that is a big fancy word for basically the steps that you use to solve a problem. So we've just done the algorithm for 34 plus 18 equals 52. Let's take a look at another problem. Pay close attention. What's different about this problem? 134 plus 18. So you can see we're adding the hundreds now. The only thing that's different is we've added one more place value. So we're going to do the same thing. Let's take a look. 100, 30, 10, 20, 30, 4. 1, 2, 3, 4. Again, I can use my chip model to represent 134 plus 18. Now be careful, where does the 1 of 18 belong? Does that go in the hundreds place, the tens place, or the ones? You should say the tens place. And again, I'm organizing that right below 18. So 10, 11, 12, 13, 14, 15, 16, 17, 18. So can I compose a new 10 in the ones? Yes. 8 and 2 more. That makes a new 10. So going to move that over to our tens place. And how many ones are remaining? There's 2 ones. Since I added a new 10, I still need to add my new groups below. How many tens do I have now? 10, 20, 30, 40, 50. I have 5 tens. So then, looking at the hundreds, did we compose a new 100 from our tens? No, we did not. So we have 5 tens, but then we go over to the hundreds and we have 100. When we look at all of those numbers, I'm going to start in my ones place and write that number directly under the ones in the vertical method. And then in the tens, I have 5 tens and then 100. So you can see all of these numbers line up. The ones, the tens, and the hundreds. So again, the steps we're using to take and to solve these is called an algorithm. Let's try another one. 107 plus 63. Using the algorithm, we will do 100. Do I have any tens? No. 7 ones. 1, 2, 3, 4, 5, 6, 7, plus 63. 10, 20, 30, 40, 50, 60, 1, 2, 3. 7 and 3 more make a new 10, so I've composed a new 10. Add that there. So I have 0 ones remaining. Now I did make a new group, so over on my vertical method, I still need to put a new group below in our tens and then use that 0 as the placeholder for the place value of ones. There are 0 ones and 1, 2, 3, 4, 5, 6, 7 tens. So then I can go over here and add a 7 and 100. Perfect. So as you can see, adding a place value, an extra place value, the hundreds, is no different than adding the tens and the ones. So we'll continue to work on that.